Hey y'all, well I'm finally back to make another episode for this DIY electrical channel. I had a little bit of stuff going on, so I'm sorry I haven't made a video for the past few weeks. But today's video is going to be about, and I think I mentioned it at the end of my last video, but it's going to be about my generator. So I'm going to show you my generator and how I have it hooked up into my panel so that I can use it whenever my power goes out. Now, it's nothing fancy. I don't have some sort of a generator that's in, standby that cuts on when the power goes out and all that. It's just a regular gas generator that, well, when the power goes out, you crank it up. It's gas powered. Crank it up, and I'll show you how I plug it in and what steps that I take in order to safely use it for my house. And I have used this generator several times, and I've had all the appliances running in my house. So I've left the hot water heater on, I've left the air conditioner running, lights on, you name it. I do try and conserve electricity as much as possible because it's not that big of a generator. And I have tripped the breaker on it once when I tried to cook. So I plugged in a griddle and while the power was out, and that was the final straw for it. It couldn't handle that load and it tripped. But anyway, so yeah, I'll take you over and I'll show you exactly what's going on with it. So let's head over there. All right, well here we are at the generator here. Make sure I'm zoomed out. Yeah, okay, there we go. Now you can see this is a Powerhorse 13,000 watt electric start generator. So its peak output, its peak power output is 13,000 watts. That's peak. That's not, it's not going to continuously run at that. In fact, and I'll tell you this, so in order to get your power, you multiply voltage times current. So obviously we know that, I'm going to hook this up into my main panel, so I want to get 240 volts out of it because that's what it's going to take to power your double pole breakers, so your hot water heater, your stove, your oven, your air conditioner, all that. I want to be able to run that when the power's out, so I'm going to hook it up 240. So in order to get my, if I was going off this peak, this 13,000 watts, I would do 13,000 and I would divide that by 240 volts to get my peak current output, which would be around 54 amps. But here's the thing, right? So I'm gonna turn this over. I'm gonna zoom in a little bit here. You can see that rightmost plug is AC 120 volt, 240 volt, and you can see it has that AC main breaker over there. Now that is a 40 amp breaker, and it says that you can't see it because it's hidden under the tab. Here, let me lift this up for you. So you can see this here, it says 40 amps under there. So that breaker is only going to output 40 amps. So as long as that's how you're hooking it up in your panel, and that's what I'm doing, this generator is only going to output close to 10,000 watts to my main panel. Because that's, that breaker is going to trip if you get over 40 amps. So anyhow, keep that in mind. So 40 amps is our maximum output current here, and we're going 240 volts out of that rightmost plug. So now let's see, let me take you and show you where I plug it in outside. Okay, so this is right outside of my garage where I keep my generator, and actually if you watched my last video and I was talking about how electricity comes in your house from the street, I showed you my meter box. Well, this is directly under my meter box here. So this plug, you lift that up and there's your plug right there. once you start the, you start the generator up. Well, actually, I do it before I start the generator up. So I wheel it out here, and I've got a cord that I'll show you that I plug into that plug I showed you on the generator. The other end plugs in right there. Now let me show you directly on the other side of this wall is my main panel. So I'm going to take you in there and show you what's going on here. Okay, this is my main panel here, and so what they did, and I'll show you, I'll zoom in here. They installed a 2-pole breaker in there because you remember, if you watch my last video, I talk about how you get 240 volts out of this panel, right? You got 2 legs coming in. Each leg, if you measure it to neutral, gives you 120 volts. So one leg to neutral gives you 120 volts. The other leg to neutral gives you 120 volts. If you cross both legs, you measure across both of those legs, you're going to get 240 volts. And that's what these 2-pole breakers do, is they cross both legs inside this panel to give you 240 volts. And so you can see, if you can see that there, you can tell that bottom left breaker is 50 amps. And that is where that generator comes into my main panel. So if you go down here, you can see this thick black wire here is wired directly to that plug that I showed you on the outside, the receptacle that I showed you on the outside of the house. That is the wire that's coming up into the main panel, and it's wired to that 50 amp breaker right there. So so let me show you. Here's the whole panel. So my main breaker's at the top, and my generator breaker's down there at the bottom left. So that generator breaker stays off when it is not in use. Of course, my main breaker's on because I want power from the grid. So what I do, and what you have to do, is when the power goes out, right, there's no automatic transfer scheme here. I mean, big, large industrial customers and some residential, some people, they want that at their house. Usually it's, more wealthy people, because it's a more expensive setup. They can do an auto transfer where the generator's in standby and it's sensing the voltage coming in from the utility. When it drops out, they automatically do this right here. So the generator will cut on. Yeah, we'll just do it in our case. In our case, we're doing this all manually, right? So say I've wheeled the generator out of the garage. My power's out. Wheeled the generator out of the garage. I've hooked it up to that receptacle outside with a cord that I'll show you in a minute. The first thing that I want to do is come up in here, turn off my main breaker, right? That is imperative that you do that. Because if you don't, if you leave your main breaker on, and then you go out and you turn your generator on, and then you come down here and you turn this breaker on right here, your generator breaker, that's where your generator power, that's where your voltage, that's where your current's coming in to your main panel from that breaker. If you do that and you leave your main breaker on, instead of feeding your house and powering your house, you're going to send power back out to the road, and you're going to be trying to power up your neighbor's lights, and don't do that. All right, even if you want to power your neighbor's lights, it's probably not going to work anyways, because this thing's not putting out a whole lot. So don't do that. Just don't do it. So turn your main breaker off first, then turn on your breaker, whatever breaker you have designated as your generator breaker that's hooked up out there. Then you turn that one on afterwards, right? And then you go back to your generator and make sure that breaker on your generator is on, so it's outputting power. So then you're powering your house and you're not sending back. And then when the power from the grid does come back on, you come out here and you turn your generator breaker off first. Turn that generator breaker off, disconnect your generator from your main panel. That's what that's doing when you turn that breaker off. Then turn your main breaker back on to let grid power come back into your house. So always make sure that you keep grid power and generator power separate by using those breakers correctly. So now I'm going to go back down. Let's see. Yeah, we'll go back down, and I'm going to show you the cord that plugs into my generator. Okay, so let's take a look at this cord here. This is the cord right here that I use. I'll try and get this in focus here. This is the cord that I use to plug in the generator to the house when I need to use this thing. So you can see, right, and I showed you this before, one end will plug into here, the other end plugs into the house. And if you can easily make one of these up yourself. Let's get this focused here. That's all it is. Now I need to replace this because I shouldn't have these parts exposed, but this is how it was when I moved in. This guy had this stuff in here, and I haven't taken the time to fix it yet. But you can see, and this is actually a good way to show you, if you measured between this leg here and this ground or this neutral, you'd get 120 volts. If you measured between this leg here to ground or neutral, you're going to get 120 volts. If you measure across the two legs here, you're going to get 240 volts. That's how you get your 240, 120 out of this generator into your main panel to feed your house. So now I just want to talk to you a little bit, and we'll move back over and get set up, and I'll talk to you a little bit about how to size this equipment here. Alright y'all, so we talked about the generator. I showed you how it hooks up to the house and how that wire comes from that receptacle outside to that breaker in the main panel, and how to go about switching between generator and grid power in the case that your power does go out. Now say you don't have a generator yet and you want one, or you want to, or you do have a generator but you don't have it wired up like this. You don't have anything, any of the wiring done. You don't have it running in your main panel. I showed you, okay, so I told you that it's a 13,000 peak power output generator, but that the receptacle that we're using on the side of that generator to plug into the receptacle on the wall of the house has a 40 amp breaker on it. So over 40 amps, it's just going to trip that breaker. So really you're getting 40 amps out if you hook it up that way, which is about 10,000 watts. So you need to have your equipment size to be able to handle 40 amps of current. Because if you go too small, like say you use wire that's conductors that are too small and they can't handle 40 amps coming through them, they will overheat, catch on fire, could burn your house down, which is bad. You don't want to do that, right? So make sure that you do it the right way. Now, that receptacle that I showed you has stamped on it 50 amps. So it is capable of handling 50 amps. So that receptacle is fine, right? The breaker is good because it's 50 amps, even though really you're going to trip the breaker on the generator before you trip the breaker in your main panel, because one's 40 amps and one's 50 amps. So, but that's good, because if something happens with the breaker on your generator, say it doesn't trip when it's supposed to, well, you got backup in your main panel. If it gets 50 amps, that'll trip. Now, what they did, and I don't know why it's this way, I'm going to have to fix it. that thick black cable that I showed you that's hooked up between the wall receptacle and the main panel breaker, that is type NM-B 10 gauge wire. And of course it's got four wires in there. Well, 3 and a ground. It's 3 conductors and a ground. So one for each leg, your neutral, and then your ground, which your ground is usually bare copper. That wire, so if you look that wire up in the National Electrical Code, which governs basically all the electrical in your house, the requirements and all that, or you can, and I'll include a link in the description for this video. I'll include a link of a chart that you can look up online that they pull their data from the 2017 edition of the National Electrical Code that shows you types of wire, whether it's copper or aluminum, and the sizes, and it tells you what that particular wire can handle current-wise. It's called the ampacity of the wire. That wire in there is, I said, an NM-B number 10. Copper. If you look that up in the chart that I've included in the description, you'll see that that wire is only rated for 30 amps. It doesn't make any sense, right? They use a 50 amp breaker, they use a 50 amp receptacle, but then they use wire that's only rated for 30 amps. So really, I could look at that chart, and I believe it's number 8 is good for 40 amps. So I would want to go with at least number 8, maybe even, to be safe, number 6. So that's something. That's how you size that. So you're like, oh, well, what is NM-B? Well, you can look all that up. There's different kinds. There's NM-B. There's THHN. There's THWN. They're just different types of wire with different types of insulation for different applications. That NM-B is typically used, if you look it up, for residential applications like this. If you were running wire outside, it'll be a different type of wire that you want to use. But you can look up all that information on the internet. So just be aware that if you're doing that, get equipment that is rated for the amount of current that's going to be flowing through it, because you don't want your house to burn down. It's not cool. But yeah, so that's pretty much it. Obviously, I didn't go over procedures on starting up my generator, and I didn't show you how I crank that thing up, because all generators are different. You might get one with a pull rope to start it. You might have to choke it, pull rope it, or you might get one like mine with a battery on it that you just turn a key and it starts up. But what I recommend is read the documentation that comes with your generator to get that information. That's always the best bet. So anyways, that's my video on generators. If there's anything that I passed over too quickly, anything I missed, anything I wasn't clear on, as always, just leave me a comment. I will be glad to answer you, because I have yet to get a comment on one of my videos. So feel free to comment, and I will respond with whatever information that you need. Alright, y'all. Thanks.